class. Today we're going to talk about section 2.3, rate of change and slope. So we'll start with our standardized test practice problem, and it reads, the initial fee to join a gym is $200. It costs $55 per month to have a membership. Write a function for the total cost, C of X, of having a membership for X months. What is the cost of having a membership for 18 months? So the function would be C of X equals 200 plus 55X. And we want to know the cost of having a membership for 18 months. So X is going to be 18. And to write that in function notation, it would be as follows. C of 18 equals 200 plus 55 times 18. So we replace the X with the 18 in the function. And what we would end up with for the total cost, well, first of all, let's check our choices here. And the only one that has the right function listed is B, and the cost is $11.90. So our answer would be B. So the first topic in this section is rate of change. The rate of change is defined as follows. Rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. To find the average rate of change, we take our change in Y, this is called the dependent variable, over our change in X, which is the independent variable. And sometimes you might struggle with, well, what's the independent and what's the dependent? Well, in this first example, the elevation of the sun in degrees depends on the time. So the elevation is the dependent variable, and the time is the independent variable. And you can see how they worked that. They took the overall change from the last value for Y of 84 minus the first value of Y of 6, and they put that over the change in time, 11 a.m. minus 7 a.m. So that would give us 84 minus 6, which would be 78, and 11 a.m. minus 7 a.m., which would be 4 hours. And when you write your answer, you write it in the units of measure. So it was degrees per hour. So we're going to try just a couple of these examples. We're not going to do all 5 of them. Why don't we start with number 2? So we're looking for the average rate of change in altitudes per minute. Altitude is the dependent, that's the Y. So we would take the ending value of 3320 minus the starting value of 520, and we would divide that by the change in minutes, which would be 23 minus 3. So I can get the bottom in my head. The top is 2,800 So we divide the 2,800 by 20, and that gives us 140 meters per minute. Again, write your answer with in the units of measure. So it was meters. Think of this as your per, and this is your minutes. Okay, let's try numbers 3 and 4. So this time our dependent variable is meters and our independent variable is seconds. So we would take 8.73 minus 3.51, divide that by 29 minus 0. 8.73 minus 3.51 is 5.22. Obviously 29 minus 0 is 29. And that would equal 0.18 meters per second. This is also, not only do you sometimes read it as 0.18, but this is 1800 meters per second. Okay, I'm going to move that up, the next one up, so we can see it a little better. And we're going to try number 5. So again, our dependent variable is meters, our independent is seconds. So we're going to start at the bottom, 7.2 minus 37.3, that's a point right there, over 13 minus 0. The top, 7.2 minus 37.3 is negative 30.1. We're going to divide that by 13. And this time our answer is negative, which is fine. Our change is negative 2.3 meters per second. Again, meters were on top, seconds were on bottom, so we write that as meters per second. Now we're going to talk about rate of change in another way, which I hope y'all will remember from Algebra 1, and we're going to talk about the slope of a line. So we've got our equation up here. If you've got two ordered pairs, we'll call the first x sub 1, y sub 1, and the second x sub 2, y sub 2. What we put in, and notice this right here, it says where x sub 1 is not equal to x sub 2. If those two are equal, we get a 0 in the denominator. So that's an undefined slope. So we want to make sure that when we're calculating the slope, if there's an actual slope, x1 and x2 are not the same. So you do your change in y, or y sub 2 minus y sub 1, over x sub 2 minus x sub 1. I won't talk about this example. You can go back and refer to it if you would like. We will just try a few of the slope questions. There's 6 through 11 that are slope, so let's just do 3 of those. In fact, we'll just do 6, 7, and 8. So I think it's a good idea to label under the ordered pairs the x sub 1, y sub 1, etc. So that's what I'm going to do first. X, 1, y, 1, x2, y2. And then remember my formula is m equals y2 minus y1 over x2 minus x1. So we see y2 is 13. We're going to subtract y1, which is 7. Put that over x2, which is 6, minus x1, which is 4. This will give us 13 minus 7 will give us 6. 6 minus 4 will give us 2. We want to simplify if we can. So our slope, m, of the line containing these 2 points is 3. Okay, on number 7, label underneath the points x1, y1, x2, y2. We still can refer to our formula here for slope, so we take y2, which is negative 3, minus y1, which is 1, put that over x2, which is 7, minus x1, which is 5. Negative 3 minus 1 is negative 4. 7 minus 5 is 2. Simplify, m is negative 2. Hopefully you'll recognize also that I could also say that m was negative 2 over 1. That helps when we graph if we keep the 1 underneath, but when you're writing the slope itself, you want to simplify as far down as you can. Same thing with m is 3. This could also be written as 3 over 1, and that does help when we graph, when we have the slope as a fraction. All right, on number 8, we're going to label x1, y1, x2, y2. We're going to take y2, which is 3, minus y1, which is a negative 3, over x2, which is negative 4, minus 5. 3 minus a negative 3 becomes 3 plus 3. And negative 4 minus 5 is negative 9. So this would give us negative 6 over 9. M will be, we need to reduce, we can divide 6 and 9 both by 3. So M will be negative 2 over 3. I'll give you the other answers for 9, 10, and 11 in case you want to try those, but I won't count those off on your notes when you turn them in if you don't try those. But let me just give you the answers just in case you want extra practice. 9, M is 2. 10, M is negative 1/2. And 11, M is negative 2/5. Now we're actually going to take the graphs and determine our slope. So what you do is you find a couple points. There's a point here at 0, 4. And there's a point here at 5, 0. Start on the point that's farthest to the left, and we count how far up or down we're going, and then how far across we're going. If we're going down to get to the next point, then our slope is negative. So we can see we're going down. We're going down 1, 2, 3, 4 lines, so -4, and we're going over 1, 2, 3, 4, 5. Our slope is -4/5. You can check that using the slope formula if you would like, but if you can get to where you're just graphing these or just finding them from the graph, then that's less math you have to do. On number 14, we have a point at -2, -2, and we have a point at 1, 2. Remember, go from the left to the right. So this time we're going up. Our slope's going to be positive. See the difference? Here's negative going down, positive's going up. So we're going to count. We're going up 1, 2, 3, 4, and we're going over 1, 2, 3. So our slope is 4/3. On the last one, we have a point at 0, 1, and then another point at 1, -3. So we can see we're going down 1, 2, 3, 4, so -4 over 1, -4/1, which would simplify to -4. That's our lesson on rate of change and slope. I hope you each have a great day. I'll see you next time.